So we have another AMC 12 problem. So this was number 19. So we have a select quadrilateral ABCD. BCCD is given 3 and DA is 5. And the angle CDA is 120 degrees. And we want to find the shorter diagonal of that quadrilateral. So the first thing is let's draw a circle and kind of start with that. And like we kind of don't really know how that looks like, but based on kind of the given length, we can just make a rough sketch and then we can change if needed. So it says the A is the largest one. So I'll start with AD first then. So to make it a bit longer than the others. So let's say this is AD. I'll start with maybe a here. So it says CDA or ADE. So ADE should be 120. So which means if I want to make this to D, then this angle should be larger than 90 degrees. So that will be something like this. And in that case, that would be the D. So DA is 5. So I can just make that. And then it doesn't really have to be accurate. So it just to feel safe. And then we have A, B, and C, right? So since the other two is going to be 3, so based on my graph, actually, this is not looking good. But I can, maybe I can change this a bit. But if I want to make this smaller, that will be smaller figure. So which is why I don't really care if that's not accurate. So I'll just go with this anyway. So let's say this is my AB and then a like BC. So again, since I don't want to kind of work with these smaller figures, so it's okay to work on like this part to be larger. So that's what we have. And now we know that BC is 5. So this is 5. And CD is also 5. Maybe I should have done this a bit bigger. So maybe I should do this anyway. Because if I make this larger, so it looks like 90. So that's why I kind of didn't try, but it's okay. So let's try this a bit bigger. So like when I do this, that looks like a bit close to 90, which was the reason. But I hope that will work out anyway. So the A, so this is B, C, and D. So what we have is the ADC is 120 degrees, and AD is 5, CD and BC is 3. And we want to find the shorter diagonal. Well, this is a cyclic quadrilateral. We are told that, which means the angles on the opposite ends, opposite vertices should be supplementary, which means this angle B should be 60. So you can try to see if there's like 30, 60, 90 triangle because we have like 60 or 120. That might be useful. Like you can extend it and we can make drop something like that, 90s. But instead of doing this, we are talking about the like AMC 12, and usually when you have somehow like angles that the sine cosine values, so maybe using the log cosine is kind of useful because like AMC 12 has a lot of log cosine problems. So this is, I think we can do the log cosine. And also like we are trying to find the diagonals, maybe AC the shorter or BD. But if I connect A and C, since we're interested in finding diagonal, so then I can just say we can use a log cosine in both sides of the triangle, because if I use log cosine, I will find AC. And then as soon as I know the AC, I can find AB as well. So let's do that as well. So if I use the log cosine with the side AC, so the AC square would be equal to 5 squared plus 3 squared minus 2 times 5 times 3 times cosine 120 degrees. So you can just say this is equal to that. And then let's try to see if this is going to be a good number. So you got 25, you got 9. So like cosine 120 in the second quadrant, which is going to be negative value. And this is equal to one of the basic trig identities, I would say. Cosine 120 equals negative of cosine 60. And then if you remember these values, you can just tell immediately, which we need 2, because this is AMC 12. And if you don't, you can just make a 36-degree triangle or even unit circle. So you can go with that. So that should be just -1/2. So if I plug it right here, so you get -2 times 5 times 3, and that will be -1/2. So the negative will cancel, 2's will cancel. You got 15 plus 25, that's 40, plus 9, 49. So the AC squared is like 49, so AC is gonna be 7. So which means this is not the shorter one because 7 is not a choice anyway. So that is something we have now at least. So now I'm gonna use log cosine again in the other triangle, so I can at least know AB. So if I use the side AC alone, so that should be 7 squared is equal to, I'll call this is X. The X squared plus 3 squared minus 3, actually 2, times X times 3 times cosine 60 degrees. So cosine 60 was 1/2, so we already know that. And then that will give us 49 equals X squared. So this is 1/2. The 2 and 1/2 will cancel. You got just 3X, or minus 3X. But there was a 9 actually, so plus 9. So if I move everything one side, so you will get X squared minus 3X, and then minus 40 equals 0. This is kind of like good because this is factorable. So X minus 8 and X plus 5. So that means X should be 8 because it can't be negative number for the sideline. So we know the X is 8. So, but the question is, we know almost everything except what we want. So we are looking for the other diagonal, but when you have a cyclic quadrilateral, one of the like key relation that we have is Ptolemy's theorem, which I had approved of this a while ago. So if you kind of don't know that, like you can take a look at that. I'll attach this in the description, but you kind of need to know how we actually get that theorem instead of just memorizing stuff. But that's what I'm going to use now. So the Ptolemy's theorem says when you have a cyclic quadrilateral, the product of the diagonals, I'm going to say that's going to be 7 times BD is equal to the sum of the product of the opposite side of the cyclic quadrilateral. So 5 times 3 is the product of the two opposite sides, plus 3 times 8 is other two sides. So that will give us like 5, 3, and 8, 3, which is 11, 3. So, I mean, 5, actually 13, 3, which is not going to be 39. So that will be 7 times BD. So BD will be 39/7. So the question wasn't actually too challenging. So it's just really common question that AMC asks a lot. So cyclic quadrilateral, Ptolemy's theorem. So law of cosine, those are really kind of basics of the AMC 12. So if that's kind of one of the weaknesses that we have, so you probably want to do a little bit more practice on these areas, but these are really common questions. Anyway, so that was number 19. So I hope that was clear. I'll see you in the next video.